Hello and welcome to another episode of Ken Training. Today's training is going to be on this refrigerator right behind me. I'm standing in the kitchen area for the cafeteria. This is after hours for the cafeteria folks that work here, because we can't work when these people are here. They got too many people. I can't put my tools out. It's just impossible to work with on refrigeration equipment when the people are working here. Now the problem is right here. Let me show you what we got going on. So this is a true combination. It's a true product. It's a combination freezer and refrigerator. He's complaining about the freezer not being cold enough. Now you'll notice that right now the freezer is 3 degrees Fahrenheit and the refrigerator is 6 degrees Fahrenheit. Now you would think that the freezer was actually okay and the refrigerator was operating too cold. But this freezer actually during the daytime jumps up to like 36 degrees Fahrenheit. And the cafeteria folks have been working here for years and they've never complained about it before. So something new is apparently happening with this refrigerator. And I'm not sure exactly what it is. I think that it might be the evaporator fan motor. So we're going to change out the evaporator fan motor. Also, because it's so difficult to work here and I'd rather do a thorough service on this product. I've already cleaned out the condenser coil last time I was here. So I thought, possibly it was just a dirty coil and that might be the smoking gun. But no, it was not. They still had a problem even after that. They're still complaining about the cabin temperature getting too warm. So it might just be an intermittent evaporator fan motor. I'm going to change that out. And I'm also I'm also going to pull the charge and weigh the charge out and see what that is. This particular refrigerant is 404A. What else? I guess that's it for now. Once I get the doors off, I'll show you what the compressors look like, and I'll give you a tag picture of what the model numbers are, because they got 2 different compressors and 2 different refrigerants. I'll show you that. Okay, this here is the refrigerator section, and I'm just going to show you the model number. There it is, T23DT, and the refrigerant in this section is R134A, 9 ounces. Now I'll take you down to the compartment below to show you the freezer. Okay, here is the freezer, and here is the data nameplate information. You'll see that the refrigerant is 404A, and there's just 8 ounces of refrigerant there. Kind of losing my focus there. And there's the data nameplate information for this particular freezer compartment. The next step, and by the way, right there is the evaporator fan motor. I want to change out that motor today too. I have a new motor, I'll show you that. Okay, so right here is the new motor. I think it was like $200 at my local supply house. So our intention is going to be to replace that today as well. Alright, so I've already pulled the power on the unit. Right now we're going to pull off this bottom door held in by 4 Phillips head screws, and there's 2 compressors under there, one for the freezer and one for the refrigerator. Okay, so by removing the front door, this is what you're looking at. You're looking at those 2 condenser coils right there. Now the question is, which one is for the freezer and which one is for the refrigerator? Now, the one, I'm looking at these 2 ports, and I thought possibly the manufacturer would have given me port for the suction on each unit there. But after closer inspection and following the piping back, that was not true. What happened was that the compressor that is on the right-hand side, that one has, it looks like it has been changed out previously. And these two ports that you're looking at there and there are only for this one unit. They are not for the other unit. There's no taps on the other unit. So I'm trying to determine right now which unit this is. I'm actually, the probabilities is the highest. That is the unit that I'm going to be working on, because the other unit is still factory sealed. So what I've done is I've turned the, oh, and by the way, I got a tank of nitrogen here. Even though I was here last time and I blew it out just a couple weeks ago, it's built up just a little bit of dirt, not much. You can see a little bit of dirt right there. So we're just going to blow that little stuff out since we're ready to rock with nitrogen right here. And then the other item is to determine what that is. So what I'm going to do is I turn the unit back on, and I'm just going to let the refrigerator temperature come down, then use my pressure temperature chart in order to see what the pressure is on that port, on the suction port, so I can kind of get an idea of what, hopefully I can determine what refrigerant is in that system right there. But right now we're just going to take some nitrogen, blow the unit out, and then try to figure out the what refrigerant is in that right one. Okay, what we've done, we blow out the coils with nitrogen, and I've hooked up two pressure gauges so I can see what's happening on the suction and discharge. The suction is indicating 0 psi, and the discharge is indicating about 190 psi. Go ahead and zoom in on the gauges if you can. Just okay. All right, pan back for now. Okay, so now the question is, what refrigerant is that? Inside the freezer we have 404A. So if I have 404A looking at my pressure temperature chart, can you zoom in on the pressure temperature chart right here? Okay, so going to 404A to a temperature of 20 degrees Fahrenheit, coming across to the pressure, it should be 56 psi, and our gauges are not 56. It's either 0 or about 185. Now, for the refrigerator, which is 27 degrees Fahrenheit, R134A is the refrigerant. I come over here to R134A. I go to the temperature of 27. So we'll go to 25 is the closest, or 30. Let's go 27, 25. Come across, go to R134A. That says that it should be 22 psi at 25 degrees Fahrenheit. So it should be about between 22 and 26, so about 24 psi. But again, none of our readings down there say 24 psi. Well, one reading was 0 and the other one was 180. So I strongly believe that this one here is the one that I want to deal with. What I'm going to do now is I'm going to unplug the unit, let everything go to saturation temperature, atmosphere, regular ambient temperature, and then I'm just going to see what our cabinet temperatures are and see if I can get further clarification about what refrigerant that I'm dealing with. We have to do the evaporator fan motor anyways, so I'll just have both doors propped open. So I'm going to unplug the unit, start doing the evaporator fan motor, and then we'll come back and revisit this refrigerant. Alright, I'm inside the freezer compartment, and I'm starting to take off these screws right here. There's 6 of them in total, 3 on each side, and I'm just going to try to get this assembly to come down on me. Okay, right now I've got the 6 screws undone right there. This is the drain tube for the evaporator.
I'm just going to go ahead.
Alright, so I took off this cover here just to see what I was up against. It's still not coming down. I'm going to pull off these 3 screws here. I'll do that one last. And I think that might be it. I think at this point in time... Oh, wait. Okay. This bottom section is now coming down. Alright, I'm going to pull these 3 screws out here, which will allow me to drop that down to see what's going on with this light so I can get this thing down. That's what I'm going to do right now. Okay, so now that I got that opened up a little bit, I can pull this down slightly and kind of see what's going on here. Let's see here. I can't tell if this is a plug or what all that is right there. I'm not going to be able to go far with this because there's your thermostat and it's got a capillary tube right there, so I'm definitely not going to be able to disturb this much. So I'm going to try to work with this kind of tight and see if I can do what I need to do. I might have to disconnect this right here. Actually, I think I will do that so I can have a little bit more room without disturbing that capillary tube on the thermostat. So I think I'm just going to remove the thermostat and bring it up so it's just sitting up there right now. Okay, so here's the evaporator fan motor. I got it opened up a little bit. I disconnected the thermostat so I could pull this down just a little bit more. And I just loosened up the holding nut for the fan blade. Now the fan blade is coming down towards me, and I'll just label this B for bottom and T for top, so when I put it in I make sure I got the correct orientation. Alright, so I'll just put that off to the side for now. Then I'm just going to go ahead and see what the mounting is here. Looks like it's mounted in by three bolts that kind of look like these ones here. So just 1/4-inch nuts. So I'll take out those 3, and it looks like the wires that come down are going to be this one here, and then it goes to this neutral section over here. I believe this is my 2 wires that I'll need to cut out and do for the new one. So I'll work on that right now. Okay, here's your evaporator fan motor. It was held in by 3 screws on this plate here. The back side of it has 3 more 1/4-inch bolts holding the actual motor to this plate. Then I took the wire here, because it goes through a grommet. It's very difficult for you to see because of this plate right here. But basically I just followed it to here. Then I know that my 2 connections are right here and right there. So the polarity on this doesn't matter. So all I got to do is just simply cut this one here, cut that one right there. Then I can take this, come through, pull it out, and now change out the motor. Okay, so here we are. I'm just going to put a little mark right there, if I can, where the cord comes out of this, right here, out of the old one. Here's the new one right here. Just going to take off this tape that is holding it in. Okay, good. So that's what they give you for the new one right there. Okay. So now I'm going to take the old one. I'm going to pull off these. 1, 2, 3 right there. Okay. Now that plate went right like that. So what I'm going to do is just take the new motor, point it in the same direction, put that like that, this plate, and just put it right like that, the same same location, and then hopefully everything will line up with holes. Okay, so here we are. Here's the old motor right here. You know, I don't know if it had a problem or not. It spins freely. The bearings aren't seized up at all, but again, I'm just trying to be proactive here. Here's the new one right here, ready to go. So I'm going to go ahead and put the wires through and pop it up through the cabinet and attach it with the 3 screws. Okay, that's the brand new evaporator fan motor in place. The wiring went through the grommet over to here. All I got, and I've already connected everything up. All I got to do is put this together, reconnect my thermostat to where I disconnected it right here, and put this this all back together. So that's what we're on right now. Okay, so we're back to our refrigerator. The evaporator fan motor job, that's complete, all buttoned up. So I looked at the pressure gauges that I had installed on the suction and discharge to the compressor on the right. Right now they're reading 100 psi. The cabinets have been open the whole time I've been doing the job. So now I looked on my pressure temperature chart, and what I did was it's 100 psi, so I go to R404A, I go to 100 psi, and it would be about 48 degrees Fahrenheit, about 48 to 50 degrees Fahrenheit. R134A at 100 psi would be about 88 degrees Fahrenheit. So what it's measuring is inside the cabinet wall, well, wherever the thermostat. It's not a thermostat, but where the refrigerant is most for the evaporator. So actually, it'd be right up there by the evaporator. So basically, the temperature of the evaporator coil is closer to 50 degrees Fahrenheit than it is closer to, what did I say, 80 something degrees Fahrenheit, 80, 90 degrees Fahrenheit. So where the 2 ports are located is going to be for the freezer, which is 404. My next step is going to be to pull the charge so I can weigh it and see how much weight comes out of there. So that's going to be the next step that I do with this. Okay, here I am. I'm starting out with the fresh DOT tank. It's got nothing in it. I'm going to pull a full-blown vacuum on it so I can get that thing right down. So I'm going to let that sit on the vacuum for a little while, and then come back to this in a few minutes. So this way I can start off with my fresh, clean DOT tank. Okay, we're at full vacuum. Got this full vacuum is right there. Everything is confirmed. We're going to start taking the refrigerant out of the refrigerator. The refrigerator I'm working on is way over here with the doors open with my tools over there. Okay, I forgot to mention, now that I know that my tank is under a full vacuum, I disconnect the hoses, and then I got my digital scale on it, and then I want to get a weight. Because the refrigerator is all in ounces, I changed the units on the scale to ounces so I can get the most accurate tank weight. So 24 pounds, 10.7 ounces. I'll make a note of that right now, so this way I'll know how much goes into that tank. Alright, I've got everything hooked up to pull my charge. Let's see if I can show you everything. I'm solo right now. Alright, so what's happening is this set of manifold gauges over here, I've got connected to the blue. I'm connected to the refrigeration, to the refrigerator right here. I capped the other port. I didn't want to use the other port. Then what I did was I took the yellow service tube here and I connected that one to the in port on my recovery equipment. Okay. Then on the red, I just capped the red, so the red isn't doing anything over here. It's just blanked off. So I'm only just using the blue and the yellow. So then what I did was I connected the out to the tank, which was already in a full vacuum. Then what I did was I took another set of gauges and I connected the red onto the high side here. The yellow is going to my vacuum pump, which is right behind me, and the blue, actually I'm not even using the blue. The blue is just capped off. The blue isn't doing anything. Alright, so let me shut the, actually the one that I should have used. Actually, I'll leave the blue open so I can capture that header pressure right there. So then what I've done is I turned on the vacuum pump. This way I could suck down everything from the tank, including the service hose that goes to the recovery equipment right here. Okay, I'm trying to show you that. See if you can see that. So I got, this is being all vacuumed out, plus the tube, plus the recovery equipment, plus this, everything into the header on that one right there. So everything's going to be in a full vacuum. When I connect it on from the refrigerator to here, I purge this line of air to this point right here. So this line is purged and that blue handle is closed right there. So I know that that's got refrigerant and everything else on this side of that valve is in a vacuum. And so all I have to do now is just go to a full vacuum on everything, shut down the vacuum pump. Once the vacuum pump is shut off, I can go ahead and do my recovery. This technique is good because it allows you to get the most. I don't have to purge everything of refrigerant. Because this is a critical charge, it's a refrigerator, a freezer in my case, I have to be really careful. The exact amount of refrigerant, I forget exactly how many ounces it is. I'll share with you that in a minute. But when I pull the charge, I want to get the most accurate reading possible. And by doing it with this technique, you will achieve the best you can possibly get as far as how much refrigerant you're pulling out of the system. So that's it for now. I'm going to wait for this vacuum to be 100%, full vacuum, shut everything off, then I'm going to do my recovery, then weigh my tank. There we go. Alright, recovery system, the vacuum is done. Recovery system is currently on. All the valves are open. There's your pressures right there on your suction, on your discharge. And where's your manifold? There's your manifold gauges right there. You can see I already got a 20-inch vacuum on there. So pretty much I've already pulled out all the refrigerant that's in the system. And now let me share with you how much refrigerant that is. Hang on. Alright, here's your data nameplate, and it tells you R404, hold on, camera, trying to keep your focus here. The camera keeps losing the focus. But basically it's 8 ounces of refrigerant, R404A. Alright, I've disconnected my DOT tank from the system, but while I'm at it, I just go ahead and took the manifold gauges that are already connected on to the system right there, and I put them onto the vacuum pump. So I got them so I can go ahead and draw that right down into a full vacuum. So while I'm weighing the DOT tank, I'm going to let that pull into a full vacuum. So that's where I'm at. Okay, here's the refrigerant tank, and I'm weighing it now. The weight is 14 pounds, 24 pounds, 14.9 ounces. We originally started out with 14 pounds, 10.7 ounces. That equals only 4.2 ounces that I pulled out of the system. The system requires 8 ounces. I am going to go ahead and recharge the system. I'm going to use brand new refrigerant. I acquired this at on Amazon, R404A. This particular container, let's see, does it say how much weight it is? 28 ounces. I acquired this for like $40 or something like that. It was very reasonable. I didn't want to buy a big tank because I don't do a whole bunch of 404A. I bought the smallest container I could buy. So what I'm going to do now is I'm going to check my vacuum, make sure we're in full vacuum. Once I'm in full vacuum, I'm going to get ready to charge this brand new tank, 8 ounces into the system, and everything should be okay, but we'll test it and run it and all that. First thing I do is I go ahead and put my brand new tank on the scale to get a baseline, and that is my baseline. Hold on, let me pull the scale back, my camera back a second. Where are we at? My baseline is 3 pounds, 0.6 ounces. Okay, when I'm done with this, if I'm going to put 8 ounces into the system, I should have left 2 pounds, 8.6 ounces on this when I weigh it. But it'll be a little bit less than that because I'm going to purge some of the lines with this brand new refrigerant. But at least it gives me a baseline. Okay, we've achieved a full vacuum. I am going to go ahead and isolate the system right now. So the first thing I want to do is shut off my valves. Next thing I'm going to do is I'm going to shut off my vacuum pump. Next thing I'm going to do is take my service line here and I'm going to connect it onto here. Now I need to make sure that it has a depressor, which this one does. And I'm going to be live on the 404 right after I dip in here. That should be right. Okay, you heard me lose a small amount. Okay, I need to purge this line. Come on. Oh, it's tight. There it is. Okay, now that's 100% purged. Okay, we're in a full vacuum on the system. I got one line here closed. Alright, I've got my gauges hooked up. My tank is on. And I've got a scale on it right now. I got to turn the scale on and then figure out what that's doing. And then we're going to start charging this puppy 8 ounces. Okay, I've got it on. I zeroed it out. And I got it set to ounces. So once I get that down to negative 8 ounces, then I know 8 ounces is in the system. And then, so that's, everything is ready to go. I'm going to start opening up the valves right now. And we'll see what happens here. So the first thing I want to do is open up the blue. Then the next one I want to open up is the yellow. Once I open up this yellow, everything should start to happen. Okay, you can see that's getting juiced up. And what is happening to our scale here? That gets down to 8 ounces. I got to close the blue. Alright, let me open this up a little bit more. And I'd want a little bit more than 8. I'd like to see 8.5 because I'm going to lose a little bit when I pull off my fittings and everything like that. .2. I might have to turn the unit on and suck it in. I think that's what's going to happen here. I think I'm just equalized out. Yeah, I'm pretty stagnant. Alright, so the next thing I'm going to do, I've stopped at 5.2 ounces. I've got some juice in the system. What I'm going to do now is I'm going to go ahead and shut off my service that goes to the tank. I'm going to shut that off. I'm going to go and turn the refrigerator on, and then that'll turn that compressor on, and then I can use the compressor to suck in the rest of the refrigerant. Here we go. Okay, here we go. I'm going to go ahead and reconnect on that. Okay, I have to purge this line again, so I'm going to come over to here, purge that. A small amount of refrigerant. Come on. There we go. Good, plenty good. Then come back over to here and now, okay, I'm going to zero that out and I want to get about 0.6 more in the system. Here we go. Okay, oh boy, that's it, 0.7 right there. I can stop right there. I've achieved my goal. I am going to go ahead and now pull off this right here. I've already closed my service valve. turn that off. See, I keep losing a little bit of refrigerant out every time I do this too, so it's truly not even 100% true test. Let me actually, hold on, take that off, zero this out, and put that back on. Then see what that weighs. Alright, now originally I wanted it to be 2 pounds 8.6 ounces, but in reality every time I go on to the connection here, I lose a little bit of refrigerant each time, and the system had a little bit of a loss too. So I might actually, as long as I got all my equipment, all my tools, everything else, might as well go ahead and put some more refrigerant in there. I'm thinking another 0.5 ounces in there to give me a little bit of a buffer. So I'm going to go ahead, connect back on here. Hold on, see that? Okay, so I'm going to connect on there. Boom. I'm going to purge my line out. Hold on. Over here. And that is this line. Okay, we're purged out. Now, everything is fine. Unit is still running. And let's go ahead and zero that out. And I want to get 0.5 more in there. Here we go. Alright, so I'm opening and closing my service valve on the manifold gauges. Yep, there it is right there, 0.7. I think I'm pretty damn close to 8 ounces right now. I'm going to go ahead and isolate everything. So I'm going to come over here to my manifold gauges, close everything down. Okay, right there, right there, right there, right there, right there. Okay, that's all closed out, and I'm going to see what this thing does. Alright, there is my evaporator, brand new evaporator fan motor. It is still not turning. I thought that the old one may have been bad or intermittent, but now that I've replaced it, it looks like there's some other issue going on here. I have a wiring issue or something. My refrigerant in the system is fine. The refrigerator is at 8. The freezer is at now 67. I've got something going on, or there's a loose connection somewhere, and it's all due to that evaporator fan motor. So now I got to rip this up, open up this again, and figure out what's going on. Okay, hello and welcome back. So what happened was last time I told you that the refrigerator, I thought there was a wiring problem because I didn't see the evaporator fan motor turn on. So what I did was I took the model number, serial number, went on the internet, went to True's website, and got some literature, and this is what I discovered under one of their literatures. For mechanical temperature control, the evaporator fan will remain off until a specific temperature of the evaporator coil is reached. So they have a thermostat attached on the outlet of the coil of the evaporator before it goes back to the compressor, and they want that to reach a certain low temperature before the evaporator fan kicks on, because the reason why is because the freezer, the manufacturer, only wants cold air circulating in that particular unit. So what I perceived to be a problem, which, by the way, I should give a caveat right here. I'm more familiar with packaged air conditioning units than I am with refrigerators. I don't work on refrigerators that often. That's why I bought the 404A in the smallest container possible, because I only have, this was the first unit I ever touched with 404A. Never even touched one before. Alright, so at least that gives you a premise of, my experience towards this type of a unit. But all in all, I buttoned everything back up, put the thermostat somewhere towards a higher setting, because at the time I didn't think it was getting cold enough, so I wasn't sure what to expect. And here I am back the following day, and here we go. I'm going to show you right now what our readings are. Alright, so for the freezer, there's your freezer temperature right there, minus 18 degrees Fahrenheit, and your refrigerator is actually too cold. When I first came here, that was reading 0. I changed that thermostat just now on the inside to make it a little bit warmer. So it looks like at this point in time, I'm going to say that I believe I found the smoking gun. I believe the smoking gun was the lack of refrigerant. I only pulled out 4 pounds or 4 ounces or about 4.5 ounces. It needed 8 ounces. So I think that was the smoking gun in this particular case. So all I'm going to do is give this refrigerator back to the customer, tell them to use it, and monitor. I mean, at this point in time, I don't know what else to do. So that's what I am going to do. That's it. I hope you have enjoyed this video. And if you have, go ahead and click on the like button, give me some extra likes. Check out my YouTube channel, Ken Training, and I will see you later.